Hello everyone, Mrs. Hamby's here, and we're going to graph absolute value functions, but this time we're going to be focusing on our translations. So real quickly, going to review for you the translations that you're supposed to learn during our last lesson, as well as the Desmos activity we've been working on. So real quick, don't forget you got to take some rote notes on this. That way you can go back and reference. So whenever you need to, pause the video. So our goal is, by the end of this lesson, we can graph an absolute value function using our key features, including vertex, our transformations, and maybe possibly talking about x-intercepts and y-intercepts. But mostly we're going to be talking about vertex and the transformations. All right, so real quick review. That A, remember, the A is talking about a reflection. And that means if it's a positive number, our V opens up. If it's a negative number, our V opens down. Also, if our A is bigger than 1, it's a larger number than 1, then it's going to be a vertical stretch. And if it's between 0 and 1, then that is going to be a vertical compression. I like to call it a shrink, especially since this one's a stretch. The other one should be called shrink, but compression means the same thing. All right, the number in with the x. Remember, the number in with the x shifts on our x-axis, so it either goes left or right. Think of it as our ex-boyfriend or our ex-girlfriend. Our exes always did the opposite of what we wanted them to do. That's why they became our exes. So any number that's in the absolute value with the x is going to do the opposite of what you think they would do. So basically, if we had a negative h, you would think it would go to the left, but it doesn't. It shifts to the right. And those are horizontal shifts, because we're going to shift horizontally on the x-axis. So if h is negative, we're going to go to the right. If h is positive, we're going to go to the left. And then our k is fine. You leave that same sign. That's going to be your vertical shift. And if our k is positive, we're going to go up. If our k is negative, we're going to go down. So remember, it's just the x that do the opposite of what we would think. All right, here we go. Here are our steps. Remember, make sure you take notes and put them in your next set of notes. I'll be sure to update my table of contents so that way we're all on the same page, or at least close to it. All right, the first step is to graph the parent function. So basically the easy y equals absolute value of x. Then we're going to describe our transformation. What are our shifts? What are our stretches? We're going to plot the vertex. Remember, that's your h and your k. So your h is the number in with the x. Your k is the number that is on the outside. And that would be like our y. And then we're going to see if it's a maximum or a minimum. Then we're going to go ahead and stretch, compress, or reflect. And all of these have to do with the A's, where these two steps is mostly your H and your K's. We're going to talk about the A's a little bit here and describe your transformations, but mostly the stretch, compress, reflect is all talking about that number in front of that absolute value. All right, so let me refresh your memory on the absolute value parent function. We did graph this, I don't even know, a couple days ago. But I want you to notice there's not a number in with the x. So our vertex with the x is going to be 0. There's not a number at the end. So it's going to be 0. So we're going to start right here at 0, 0. And then using table of charts if you want, if you plug in 1 into your x, the absolute value of 1 is just 1. If we plug in -1, the absolute value of -1 is just 1. And so you'll see your slope. We're going to go up 1 over 1, and you're going to be consistent, up 1 over 1, because the left and right side is going to be a mirror image or a reflection of each other. And this one's going to be the same thing. And when in doubt, you're not sure, plug in numbers. When in doubt, plug it in and figure it out. So if we plugged in -5, the absolute value of -5 would just be +5. And we're going to connect those dots. So that is the parent function of an absolute value. All right. The minimum, obviously this is going to be a minimum. So I'm just going to circle this. This is a minimum because our vertex point is right here, and that is the smallest number. So that is the minimum, and it's at that point 0, 0. All right. Remember the slope, up 1 over 1, up 1 over 1, up 1 over 1. Okay, now we're going to go ahead and change it up a little bit, and we're going to put a number in with our x. We're going to put a number at the end, and we're going to have a vertical stretch. So the first thing is to state our transformations. So since that 2 is positive, I know it's going to be a v that opens up, and I know it's going to be stretch by 2. And so I'm lazy. I'm going to put just a v for vertical stretch. And then the number in with the x, remember that you always do the opposite. It's going to be a +1, so it's going to do the opposite, and it's going to be a horizontal stretch, or sorry, horizontal shift, and we're going to go to the left 1. And then at the end, that is a vertical stretch. I'm sorry, shift, a vertical shift, and we're going to go down 3. Down 3. All right, so our h and our k, remember your h is the number in with the x, so it's going to be a -1 because it's the opposite, and our k is going to be the same. It's going to be -3. Since we already know our v is going to open up because this is a positive, since our 2 is a +2, we know it's going to open up, so we know this vertex point is going to be the minimum. But you can also graph it to tell. All right, so let's go ahead and plot our vertex. You're going to go left 1, down 2, 3. That is our vertex. That is our minimum. Once you have your vertex point, remember that's that -1, -3, based on our shifts, we're going to stretch it with our 2. So normally we would go up 1 over 1. Instead, we're going to go up 2 over 1. And we're going to keep doing that. Up 2 over 1, up 2 over 1, up 2 over 1. And you're going to go the opposite. Up 2, left 1, up 2, left 1. And you'll see that this function is actually stretched a little bit. And I'm just going to connect those to make a nice absolute value function. Oh, totally missed those. Let me try that again. And that is how we're going to graph absolute value functions. All right, so I'm going to have you stop this video. Uh-oh, we can't see that. But that's going to be a +4. I'm going to write it for you, and then in the next video, you'll be able to see, hopefully. That's a +4. And so try this one yourself. Thanks for watching.